Welcome back. In this video, we're going to be reviewing for Test 2. So I've chosen some of the more common questions that I get in this unit, and we'll go over them. I do have some other homework questions in some of the other videos. So the 8.3 video, for example, has the lottery question and the drawing two socks question, and so make sure to look through those other videos. In this unit, I've done a lot of homework problems. So anyway, but let's go ahead and jump into these problems. All right, so for our first example, we've got a Venn diagram. We're given that the number of elements in A union B is 52. The number of elements in A intersect B is 3. The number of elements in A is 24, and the number of elements in A complement union B complement is 66. All right, so our Venn diagram, the intersection is Y. It's labeled Y. The elements just in set A are labeled X. The elements just in set B are labeled Z, and then the elements outside of both circles is labeled W, and so we want to find each of those regions. So let's go ahead and label our Venn diagram. So we know the intersection is 3. We always want to start in the middle. So that's going to be Y. So we already know that one. We know Y is 3. Let's see. We're told that A is 24. So A is going to be regions X and Y. So those two need to add up to 24. So that tells us that region A is going to be 21. Or region X is going to be 21, rather. All right, and then we're told the union is going to be 52. Now, the union of A and B would be X. We could write it as X plus Y plus Z, because it's all three of those regions together. So those three regions added together needs to give us 52. So 21 plus 3, that's X plus Y, that gives us 24. So what else do we need to add to get from 24 to 52? And the answer to that is 28. So we have Z, that's 28. All right, and then W is the last one. So this is the one that tends to trip people up. So W, A complement union B complement, let's kind of break this up. A complement, if we wrote out the elements for A complement, that would be the things not in A. So that would be Z and W. And then if we wrote out the elements in B complement, those would be the ones not in B. So that would be X and W. So the union, A complement union B complement. Remember, when we're taking the union, we just put all of the elements together. So we're putting together X, Z, and W. W occurs twice, but we don't write it twice. So X, Z, and W. So all three of those are in the union of A complement and B complement. Now, unions and complements are kind of confusing because that says A complement, union B complement. So people often want to think that means it's not in A and also not in B, but that's not true. What it means is we're putting together everything that's not in A. So I'm highlighting that now. So we're putting that together with everything that is not in B. So now I'm highlighting that. So everything in A together with everything that is not in B. And so what we notice here is the only thing not highlighted is Y. X is highlighted because it's not in B. Z is highlighted because it's not in A. And then W is in neither. So we can kind of see here by these colors, W is kind of the overlap. So it turned green because I highlighted it yellow and then I highlighted it blue. So region Z is not in A. Region X is not in B, and then region W is in neither of those, but all of those count. So what that tells us is that X plus Z plus W equals 66. So that's 21 plus, we know Z, 28. So that's 49. Plus W equals 66. And so 49 plus what gives us 66? And that would be 17. And so that is what region W is. All right. So be careful of unions and complements. We're going to look at a couple more of those as we go because those are some of the most confusing. But anyway, all right, let's move on to the next question. All right, the results of a survey taken by a bank in a medium-sized town are shown in the table. The survey asked questions about the investment habits of bank customers. Assuming that no one invests in more than one type of investment, and using the letters in the table, find the number of people in each set. All right, so we won't do parts A and B. We're going to skip down to parts C, D, and E. So one thing I'm going to do with this table is to make it a little bit easier, I'm going to cross off the totals. This actually makes it a little bit easier. So I would recommend when you're doing these, write out your table, but don't worry about writing out the totals. Because if you're trying to use the totals, often you're going to end up having to subtract things out, and it just gets fairly complicated. So anyway, all right, so we want to do Y intersect S union B. That's the first one. So let's first find S union B. So S union B would be everything in S put together with everything in B. So I've put that, I've put a red box around that. Now we want to intersect that with Y. Okay, so we want to intersect that with Y. So now I'm going to circle everything in Y. All right, so the intersection is just literally where those two things intersect. My kind of orange circle and then my red box. And those intersect at 7, 2. So 7 and 2, so that gives us 9. All right, now let's look at the next one. We'll erase those marks there. All right, the next one, O complement, union, S union A. Okay, so we have a union with a complement. So this one's going to be a little bit tricky. Let's do S union A first. So S union A, I'm going to put a red box around everything in S and everything in A. All right, and then it says union O complement. All right, so now I'm going to circle everything that is not in O. All right. Now, we wanted to do the union of those things. So that's the union of the things I circled in orange and the union of the things I put a box in red. So union means we put all of those things together. So we're not looking for the things that are in common. So a common misconception here is that we should add 7, 2, 17, 11, 6, and 17 together, which that's part of it. But we also need to add the 31 and 11. So we're adding together everything that's in S and everything that's in A together with everything that's not in O. And so all of those things that we circled or put a square around, all of those things are counted. So we're going to add 7, 2, 17, 11, 6, 17, 31, and 11. And that's going to give us 102 people. So when we look at unions, look at one piece, and then separately look at the other piece, and then put them together. All right, let's move on to the last part. M complement, union O complement, intersect B. All right, so let's write this out. So M complement would be the things not in M. So that would be Y and O. All right, and then O complement, that's the things not in O. That's Y and M. So if we want M complement, union O complement, that means we're just putting all of those things together, right? So the Y, O, Y, and M, we're going to put all of those together. So we get Y, M, and O. All of those things are either not in M or not in O. So I'm going to put a red box around those things. Y, M, and O. And what we see is that's everything. Because everything, every one of those age categories is either not an M or not an O. Y is in neither of them. M is not an O. O is not an M. So all of them are either not an M or not an O. Now we want to intersect that with B. So I'll circle the things in B, 2, 6, and 22. And so the intersection of those two things, we're looking for the intersection. The intersection of those two things would be the things that that are in the red box and also in the orange circle. So that's the 2, the 6, and the 22. So we add those together and we get 30. All right, let's move on to the next one. All right, a survey of people attending a Lunar New Year celebration in Chinatown yielded the results shown to the right. Answer parts A through D. All right, so this one is a 3-circle or a 3-set Venn diagram. When you're doing the Venn diagrams, always make sure to draw the rectangle around the outside, because if you don't, it's really easy to forget that you need a number out there. All right, so I'm going to label these regions R1, R2, R3, R4, R5, R6, R7, and R8. All right, so what we want to look for first are things that tell us about basic regions. So each of those R regions is a basic region. So, for example, 129 were women. We need to label our Venn diagram, of course. So let's make this women, Cantonese, and then firecrackers. How we decide how we label the Venn diagram, we just want to make sure not to put both something and its opposite in two different sets. So, for example, we don't need a different circle for Cantonese and people who don't speak Cantonese. In the Cantonese circle are people who speak Cantonese. Everyone not in that circle doesn't speak Cantonese. We don't need a separate circle for it. It's just by definition, if they're not in the circle, then they are outside of it. All right. So let's, often starting at the bottom of the list is helpful. So it says 31 of the women who spoke Cantonese lit firecrackers. So they're women, so they're in the women's circle. They speak Cantonese, so they're in the Cantonese circle, and they lit firecrackers. So they're in the firecracker circle. So that's region 5, and that's going to be 31. All right, and then it says 78 non-Cantonese speaking men did not light firecrackers. So they don't speak Cantonese, so they're not in circle C. They're men, so they're not in circle W, and they didn't light firecrackers, so they are not in circle F. So that means they are in region 8, 78. So notice so far, each of these has referred to just a single region. So this was region 5, that was just region 8. All right, the next one, 22 of the non-Cantonese speaking women lit firecrackers. So that actually tells us about a basic region as well, because they're non-Cantonese speaking, so they're not in the C circle, but they're women who lit firecrackers. So if we look at the region of women who lit firecrackers, but we know they didn't speak Cantonese, then what we're left with is just region 4. So that is just region 4. So region 4 is 22. All right. Now, the next two, as we're moving our way up, are the tricky ones. So 98 of the men did not light firecrackers. All right, so 98 of the men did not light firecrackers. So first, let's figure out where the men are. So let's do that by identifying, so there's women. So I'm highlighting women. That's regions 1, 2, 3, or 1, 2, 4, and 5. So if that's women, then everything outside of that is men. So men is regions 3, 6, 7, and 8. So now we just want to say, okay, of those regions, which of those regions did light firecrackers and which of those regions did not light firecrackers? So again, we're looking at regions 3, 6, 7, and 8. So regions 7 and 6, those are in the firecracker circle. So those people lit firecrackers. So the ones that didn't light firecrackers, that's regions 3 and 8. So we're going to write that region 3 and region 8. So those two need to add up to 98. Well, region 8 is 78, so that means region 3 needs to be 20. That way those two regions add up to 98. All right, let's move up again. 107 of the men spoke Cantonese. Okay, so this time let's start with Cantonese. So I'm going to highlight everyone who speaks Cantonese. Okay, so let's look at that Cantonese circle. That's regions 2, 3, 5, and 6. Now, 2 of those regions are in the women's circle, region 2 and region 5. 2 of those regions aren't in the women's circle, which means they're men, and that would be region 3 and region 6. So region 3 and region 6 are men who speak Cantonese. So let's write that down, region 3 and region 6. We already know region 3, it's 20. So region 6 would need to be 87, so that 20 plus 87 gives us 107. So 87. All right. Now, the next ones are just the sets themselves. So lit firecrackers, that's going to be regions 4, 5, 6, and 7. We already know regions 4, 5, and 6, 22, 31, and 87. So what we can do is we can take 174 and subtract out 22, 31, and 87. And what that's going to give us is 34 people in region 7. 152 spoke Cantonese. So in Cantonese, that's regions 2, 3, 5, and 6. We already have regions 3, 5, and 6, 20, 31, and 87. So we can add those numbers together and then subtract from 152. That's going to give us 14 for region 2. And then finally, 129 were women. So that's regions 1, 2, 4, and 5. So we'll add up regions 2, 4, and 5, 14 plus 22 plus 31, and subtract that from 129, and we'll get 62. All right, so then the questions we're asked are, how many attended, first of all? So that's just going to be everybody. That's going to be all 8 regions added together. And all 8 regions added together gives us 348. The number, how many of those attended did not speak Cantonese? So that would be everyone outside of the Cantonese circle. So I'm kind of crossing out the ones we don't want to add. So that'd be everyone outside of the Cantonese circle. So that would be regions 1, 4, 7, and 8. So 62 plus 22 plus 34 plus 78. It's going to be 196. Alternatively, we could have just taken 348. That's the number of people who attended, and subtracted out the number of people who spoke Cantonese, 152, and that would have given us that answer as well. All right, then how many women did not light firecrackers? So let's look at our women's circle. So that's regions 1, 2, 4, and 5. So regions 4 and 5 are in the lit firecracker circle. Regions 1 and 2 are not. So that's 62 plus 14. That's going to give us 76. Women did not light firecrackers. All right, last one. Number of those who lit firecrackers who were Cantonese-speaking men. So they lit firecrackers, so they're in the firecracker circle. They speak Cantonese, so we'll start off, they lit firecrackers, but we also know they speak Cantonese, but we also know they're not women, so that's going to leave us with just region 6, 87 people. And so that's how we do that one. All right, let's move on to the next one. Color blindness is an inherited characteristic that is more common in males than in females. If M represents male and C represents red-green color blindness, use the relative frequencies of the incidences of males and red-green color blindness as probabilities results in the values below. We want to complete parts A through F. We're gonna skip a couple of those. We're gonna do just D, E, and F. So anytime you see intersections and unions, chances are you're going to be drawing a Venn diagram, unless you have more than 3 sets. In the example of our table earlier, we needed a table instead of a Venn diagram. But here we just have 2 sets, M and C. So let's go ahead and draw our Venn diagram. So we'll label the first one C and the second one M. We'll label the regions, region 1, region 2, region 3, and region 4. All right, so we're told the intersection is 0.026, so that's region 2. So that's region 2. We're told that P of C is 0.044. C is region 1 plus region 2. So that's something plus 0.026 gives us 0.044, and that something is 0.018. So we just subtract 0.044 minus 0.026. And then M union C is 0.453. That's region 1 plus region 2 plus region 3. We already know regions 1 and 2, so we can add those together, which is going to give us 0.044. And then we'll subtract that from 0.453, and that'll give us 0.409. All right, now these are probabilities, so we can figure out region 4 by knowing that all of our probabilities need to add up to 1. So regions 1, 2, and 3 add up to give us 0.453. So if we subtract that from 1, we get that region 4 would have to be 0.547. All right, so we want to find M complement intersect C complement. So that's, it's not in M and it's not in C. So that's 0.547. Remember, that's very different than M complement union C complement. So we want to make sure we know the difference between those two things. All right, part E is C intersect M complement. So that is, it's in C and also at the same time, it's not in M. So that's just region 1. That's 0.018. It's in C and it's not in M. All right, then the last one. Unions. So unions with complements. I've mentioned these a couple times already. Unions and complements are tricky. So let's write these out. So C is region 1 and region 2. M complement is region 1 and region 4. So those are the regions that are not in M. So C union M complement would be region 1, region 2, and region 4. So all of those. So let's look at it. So M or C, let's start with C. It's regions 1 and 2. Union with M complement. So that's everything not in M. So now I'll shade everything not in M. So everything that I've shaded, whether it's yellow for C, or whether it's blue for M, or whether it's green for the part that's both, not in C and not in M, doesn't matter. All of those count, 1, 2, and 4. So we're going to add 0.018 plus 0.026 plus 0.547, and that's going to give us 0.591. So remember, with unions, and especially with complements, but just unions in general, look at the first part, then look at the second part, then combine them. Don't try to look at them both at the same time. Looking at them both at the same time is what the intersection is, not the union. All right, let's move on to the next one. How many 6-person committees are possible from a group of 8 people if A, there are no restrictions? Okay, so we can start with that one. If there's no restrictions, so first of all, here there's no mention of order, and there's nothing that would tell us that order would matter. If we're just selecting a committee of people, then order doesn't matter. Order matters when the people or things we're selecting are going to be different from one another. So for example, if I was the boss at a job and I was giving 3 of my 5 employees promotions, if that promotion is the same for all 3 people, then the order doesn't matter. Whether you're chosen first or third, you get the same promotion. But if the first promotion had a 10% raise, and the second promotion had a 15% raise, and the third promotion had a 20% raise, then it matters, right? You want to be the person chosen that gets the highest raise, the biggest promotion. So, same thing with a committee. If we're just choosing a generic committee, order doesn't matter. If we're choosing a generic committee where one person is the organizer, where one person is the planner, where another person is... So if they have different jobs, that would be where order matters, because if we rearrange the order, then people have different jobs. Anyway, all right, so here, it's just going to be a 6-person committee. You're either on the committee or you're off the committee. If you're on the committee, it doesn't matter whether you were chosen first or 6th, you're on the committee. All right, so that tells us we're going to be using combinations. So if we just want to choose 6 people for a committee out of 8 people, that's fairly straightforward. That's combination 8-6. We have 8 people to choose from, and we want to choose 6 of them. And so combination 8-6 is 28. All right, the next one, the number of 6-person committees if both Jim and Mary must be on the committee. Okay, so Jim and Mary are part of the 8 people. So now we're splitting it up into 2 groups. So we've talked about before how we're distinguishing things. So in this example, we are distinguishing people based on whether they are Jim and Mary or whether they are anyone else in the group. So we have 2 groups of people. We have the Jim and Mary group. That is 2 people. And then we have what I'll call the others, which is everyone who's not Jim and Mary, but who are the rest of the 8 people. And there are 6 people in that group. All right, so for part B, we want both Jim and Mary. So from that group, so we're going to have a combination for each group. We're going to have a combination for the Jim and Mary group. And then we're going to have a combination for the others. Because remember, anytime we're splitting things up, anytime we're distinguishing between things, we need a combination for each different type of thing. So we kind of have subgroups here. We have a group of 8 people, but within that, we have a subgroup of Jim and Mary and a subgroup of the other people. All right, so from the Jim and Mary group, there are 2 people in that group. The others, we know there are 6 people in that group. So that comes from the 2 and the 6. So part C, actually, doesn't even matter what part C says. We're still looking at Jim and Mary and the others. So part C is actually going to start off the exact same. There are 2 people in the Jim and Mary group, and there's 6 people in the rest of the group. The only thing that's going to change between parts B and C are how many people we want from each. So for part B, we want both Jim and Mary on the committee. So that means from those 2 people, we need to choose both of them. So that's combination 2-2. Now, that's 2 people from a 6-person committee, so that means from the other group, we would need to choose 4, because we want to choose 6 total. We chose Jim and Mary, now we need to choose 4 more. So we're going to multiply those combinations together because we want both Jim and Mary, and we want 4 more people because we need a 6-person committee. So part B, combination 2-2 is 1. Times combination 6-4, which is 15. So 1 times 15 gives us 15. So 15 different committees that contain both Jim and Mary. All right, part C, the number of 6-person committees possible if either Jim or Mary, but not both. So now what we're saying is from the Jim and Mary group, we don't want both of them, but we want one of them. So that would be combination 2-1. So if we've chosen one person from the Jim and Mary group, and we need a 6-person committee, that means we need 5 people from the other group. And again, we'll multiply these combinations together because we're going to choose either Jim and Mary, and we're going to choose 5 other people. And so that's going to give us 12. Combination 2-1 is 2. Combination 6-5 is 6. So 2 times 6 gives us 12. All right, let's move on to the next one. All right, 5 cards are chosen at random from an ordinary deck to form a hand in poker. In how many ways is it possible to get the following results? All right, first of all, we want to know how many ways is it possible to choose exactly 2 clubs. All right, so we want 5 cards in our hand. So in this hand, we're going to have two different types of cards. So I'm going to draw two lines. We're going to have clubs, and we're going to have non-clubs. Because we're told we're going to have exactly two clubs, which means the other three cards are not going to be clubs. All right, so for clubs, remember that our N and our R have to have the same, they have to refer to the same type of object. So in this case, clubs. So we want to choose exactly two clubs. Well, so our first number should be how many clubs are there? Well, there are 13. And then our second number is how many of them do we want to choose? And in this case, that is 2. Now, that's not all we have to do. We have to account for the 2 clubs that are mentioned, but we also have to account for the 3 cards, because we want 5. We have to account for those other 3 cards. And those other 3 cards are going to be non-clubs. So they'll be hearts or diamonds or spades. So our combination there, so how many non-clubs are there? Well, there are 13 hearts, 13 diamonds, 13 spades. So that is, there are 39 non-clubs. We could have also found that by subtracting the 13 clubs from 52. And then how many non-clubs do we want? Well, if we want exactly 2 clubs and 5 cards, that means we need 3 non-clubs. So we'll multiply those together, combination 13, 2 times combination 39, 3. And what we're going to get is 712,842. So quite a few different card hands. All right, part D is how many ways is it possible to choose at least 2 clubs? All right, now this one, there's a way that seems like it would work, and that is to do combination 13, 2 times, and then only take out some of the clubs. But anyway, the way this works is when we do it like we're doing here, each combination has to be independent of the other. We can't include some cards in one that are also going to be included in the other. So we can't do this with just one set of combinations like we did the previous problem. At least 2 clubs, at least 2, we want to think about what that means. So this is going to be really important in Unit 4 as well when we get to binomial probabilities. We're going to have a lot of at least, at most, and we're going to need to think through what does that mean. So at least 2. So we have a 5-card hand. At least 2 clubs means 2 clubs, or 3 clubs, or 4 clubs, or 5 clubs. All of those are possibilities. Everything between 2 and 5, again 5 because that's how many cards we're choosing, everything that is at least 2 is listed there, 2 or 3 or 4 or 5. So we have to calculate each of those individually. And we actually already calculated 2 clubs, so we already know this one. Now we just need to do 3, 4, and 5. So let's just write them all out. So 2, 3, 4, and 5. So 2, we already did that one. That was combination 13, 2 times combination 39, 3. That was the previous part. All right, 3 clubs. Well, that's 13, 3. We want 3 clubs. And if we want 3 clubs, that means we only need 2 other cards. So that's 39, 2. And then for 4 clubs, that's 13, 4, because we want 4 clubs. And if we want 4 clubs, then we only need 1 other card. So that's 39, 1. And then 5, that's combination 13, 5, because we want 5 clubs. And then combination 39, 0, because if we're choosing 5 clubs, then we don't need any other cards. All right, so then we're just going to add all of these together. So we'll calculate all of those combinations and then just add them all together. And we add them because we can have 2 clubs or 3 clubs or 4 clubs or 5 clubs. So remember, anytime we have options, that's when we're going to add. So what we're going to end up with is 953,940 ways to get at least 2 clubs, which would be 2 clubs or 3 clubs or 4 clubs or 5 clubs. All right. Well, those are some of the most asked about questions. Again, as a reminder, there are other homework questions worked out in some of my other videos. So if you're stuck on some of them, make sure to watch those other videos. But that's it for our review for today. Good luck on the test.